We got 50,000 people around the world who just thought this was an inspirational thing to invest in. So together, we built a spacecraft, a real spacecraft.
3, 2, 1.
Hey, Bill Nye here at the Planetary Society talking about solar sailing. Now, most spacecraft get pushed through space with some kind of rocket fuel. The momentum of the fuel going this way pushes the spacecraft that way. Here, take a look. Now, if I had been in space, I would have drifted away. There are a few different types of fuel that are used in space travel, but they all come out of an onboard fuel tank. So they all eventually run out of gas, if you will. And when they do, that's it. They're done. No more propellant means no more push. No more push. But a solar sail spacecraft like this one doesn't need ordinary rocket fuel. Instead, it gets pushed through space with a free supply of energy, the pressure of light. Light is made up of particles we call photons. So imagine this ping pong ball is a photon, a single particle of light. Now, photons weigh nothing. They have no mass, but they still have momentum. If we have a spacecraft that's low enough mass and big and reflective enough, then photons can give it a little push. Each photon imparts just a tiny bit of momentum, but the sun pumps out billions and billions of them every second. Now imagine this happy cookie sheet is the reflective sail of a spacecraft. Whoa! It gets a push through space. In the vacuum of space, it really works. Solar sailing is a game changer. These spacecraft can be steered a lot like sailing ships at sea. They can be pushed away from the sun or turn and tack toward the sun. Now, someday soon, we could be sailing around the solar system with the unlimited energy of sunlight. And maybe one day in the future, we could even sail one to another star. Solar sails will be pushed through space by sunlight.
Space, the final frontier. Within that mystery are profound secrets that apply to all of us, all species and all philosophy.
This is a letter written by Gene Roddenberry. The essence of the Star Trek missions are to discover, to learn more about our universe, and to apply that knowledge to the benefit of mankind. It is this idea which the Planetary Society is devoted to.
I fell in love with space the first moment I stepped foot onto the set of Gene Roddenberry's vision for Star Trek. The Planetary Society understands that vision for a better future.
You know, exploration is in our DNA, and I think that's just part of the way we are as human beings. It's in our nature. A wonderful organization dedicated to the exploration of space is called the Planetary Society.
I encourage you to go to planetary.org and to become a member.
The Planetary Society is bringing us closer to Gene's vision of a better future. So, are you with us?
We got 50,000 people around the world who just thought this was an inspirational thing to invest in. So together, we built a spacecraft, a real spacecraft.
3, 2, 1.
Hey, Bill Nye here at the Planetary Society talking about solar sailing. Now, most spacecraft get pushed through space with some kind of rocket fuel. The momentum of the fuel going this way pushes the spacecraft that way. Here, take a look. Now, if I had been in space, I would have drifted away. There are a few different types of fuel that are used in space travel, but they all come out of an onboard fuel tank. So they all eventually run out of gas, if you will. And when they do, that's it. They're done. No more propellant means no more push. No more push. But a solar sail spacecraft like this one doesn't need ordinary rocket fuel. Instead, it gets pushed through space with a free supply of energy, the pressure of light. Light is made up of particles we call photons. So imagine this ping pong ball is a photon, a single particle of light. Now photons weigh nothing. They have no mass, but they still have momentum. If we have a spacecraft that's low enough mass and big and reflective enough, then photons can give it a little push. Each photon imparts just a tiny bit of momentum, but the sun pumps out billions and billions of them every second. Now imagine this happy cookie sheet is the reflective sail of a spacecraft. Whoa! It gets a push through space. In the vacuum of space, it really works. Solar sailing is a game changer. These spacecraft can be steered a lot like sailing ships at sea. They can be pushed away from the sun or turn and tack toward the sun. Now someday soon we could be sailing around the solar system with the unlimited energy of sunlight. And maybe one day in the future, we could even sail one to another star. Solar sails will be pushed through space by sunlight. We got 50,000 people around the world who just thought this was an inspirational thing to invest in. So together, we built a spacecraft, a real spacecraft.
3, 2, 1.
Space, the final frontier. Within that mystery are profound secrets that apply to all of us, all species and all philosophy.
This is a letter written by Gene Roddenberry. The essence of the Star Trek missions are to discover, to learn more about our universe, and to apply that knowledge to the benefit of mankind. It is this idea which the Planetary Society is devoted to.
I fell in love with space the first moment I stepped foot onto the set of Gene Roddenberry's vision for Star Trek. The Planetary Society understands that vision for a better future.
You know, exploration is in our DNA, and I think that's just part of the way we are as human beings. It's in our nature. A wonderful organization dedicated to the exploration of space is called the Planetary Society.
I encourage you to go to planetary.org and to become a member.
The Planetary Society is bringing us closer to Gene's vision of a better future. So, are you with us?
Space exploration truly brings out the best in us, encouraging people from all walks of life to work together to achieve a common goal, to know the cosmos and our place within it. We are the Planetary Society. In a morning like this, you really feel it. Here's the ocean, it's the sunrise, and then beyond that is space. And we're just part of this whole enormous thing, the cosmos. Are we unique to the cosmos? Are we the only organism that ponders its place in space? Carl Sagan talked about this dream of sailing through space pushed by photons, the physics of light. And he talked about this in practical terms and very romantically back in the 1970s.
Let's talk about this. This is interesting.
Well, there's a just tremendously exciting prospect called solar sailing, and which travels on the radiation and particles that come out of the sun, the wind from the sun.
And so this dream of Carl Sagan's, Bruce Murray, and Lou Friedman, the founders of the Planetary Society, is going to be realized at last. You know, we flew a test flight 4 years ago. Got on orbit, as they say, and it flew well enough, but there were some communication difficulties that were overcome. So we've had several years to sort out those software problems, those solid engineering problems. And now we're going to do it for real. We're going to go edge on toward the sun, rotate, get a push, rotate, get a push. Regular rockets run out of fuel. Sooner or later they run out of fuel. But a solar sail, no. As long as there's a star, you get a push. It's really amazing. It's relativistic, it's physics. I mean, I think Carl Sagan would be very proud of this effort. It's a small spacecraft, but it's an enormous story. We got 50,000 people around the world who just thought this was an inspirational thing to invest in. And we're doing this just to advance space science and exploration because we want to know more about the cosmos and our place within it. We want to know more about where we fit into this whole thing. So together, we built a spacecraft, a real spacecraft. And this is one more step in understanding it all. I sure hope it flies and everything works as well as we hope it will.
Very exciting to see you observing as the CEO of the Planetary Society, observing the project close at hand. Carry on.
The morning test didn't work so well. There were a lot of anomalies, a lot of little problems. So we'll see if the afternoon test goes well. So right now the spacecraft is booting up. It looks like we're just standing here watching it, which we are, but it's also booting up.
You're go for sail deployment.
Ready to go.
2, 1, boom.
And that's it. Professor Sagan, this one's for you. The history of solar sailing, it depends when you want to start counting. I mean, for me, I was in Carl Sagan's class in the spring of 1977. And he was talking about this mission to Comet Halley, we used to call Halley's Comet.
It can get you around the inner part of the solar system a lot faster and a lot more conveniently than the usual sorts of rocket propulsion. See, it's a whole new kind of idea.
Anyway, that mission got canceled, fine. Comet Halley got canceled. But the whole thing really you can say goes back to Johann Kepler in 1607 and 08 when Comet Halley came by the Earth back then. He reasoned that whatever was creating those tails was from the sun, sunlight. And it was right. I mean, that's true. And so he proposed that people would one day be sailing on sunbeams, starlight, even back then.
Speaking of scientific advancement, you've written a book called Star Sailing, Solar Sails and Interstellar Travel.
It's an idea of you hoist a big sail up and you use sunlight pressure to go around the solar system.
1985, Lou Friedman publishes his book about solar sailing. It sounded like the coolest thing to me as an engineer. It just sounded so elegant. There's no fuel. If you got materials that can handle radiation and heat from the sun, you could get going 100 kilometers a second and shoot to flipping anywhere.
So you can actually see the big spring inside the P-pod deployer device that's basically like a jack-in-the-box. So they'll push the light sail down into it, and then when they release the doors in space, the spring will push the light sail off on its ride in space.
I'm originally from Germany. I live in Florida now. I'm a fresh member of the Planetary Society, and this is my first Planetary Society event.
Really excited to see this. It's going to be crazy. It's going to change space exploration forever.
There is another payload on LightSail 2. And Jennifer, I wonder if you could talk a little bit more about the DVD.
Yes, the Planetary Society has a whole history of sending us somehow to space. So maybe it's your name, maybe it's a piece of information, a message that you want to send. And so for LightSail, what we did was we sent the names of all of our members. This is one of the things we do quite often. But we also gave an opportunity to do selfies to space. So you could send a picture of yourself as well.
To me, the LightSail program is laying the groundwork for operational use of solar sails to go do science missions. And that's what NASA's doing with the Near-Earth Asteroid Scout mission, which is going to launch on the first Space Launch System launch. And that mission is going to use a solar sail to go out and do science in an asteroid. And that's a beautiful follow-on to the LightSail program. They've been following along with us every step of the way. They've been coming to our reviews, they've come to our major tests, and we've had a NASA Space Act agreement, so we've been sharing information with them all along the way. So to me, that is LightSail 3. You know, that's a beautiful follow-on to the LightSail program.
Thank you all so much for making the trip, for coming here and supporting us, because we really are making space history, space exploration history, and we're doing it together.
Hi, my partner couldn't come because she's in law school and she couldn't get the time off. But this has just been so inspiring.
Let it dry, let it dry, let it dry.
Thank you.
My name is Isabel Kahan. I'm from Vienna, Austria.
My name is Gerald Leitschmidt, and I'm also from Vienna. I think it's super cool that you actually don't need any fuel, so you can just go forever. I think that could actually leapfrog human space exploration. So that's actually why we're here, just to see if it goes up. Learning about space is learning about humanity and learning about our past and our possible futures.
Being a part of the community, a big community who is excited about space exploration.
Go LightSail 2!
Oh, sorry.
Go LightSail!
My name is Naila Irwin, and I travel from Happy Jack, Arizona. I'm a charter member of the Planetary Society. I joined in 1980, and my charter number is 882. This is my first launch, and we are just delighted to be here. So I'm looking forward to it very much. Even though there's been a delay, we don't care.
I have been a member of the Planetary Society for 5 years. I joined with my dad, and it's been a blast.
You don't think that light can actually add propulsion to something, and the fact that we've discovered that and we can use that in our future means that there's possibilities that are endless.
I mean, it's amazing. I've been so inspired by space my whole life. Being able to actually see a project come to fruition and launch into space is a dream come true for me.
Yeah, they do.
God, you guys, look at the
I know, isn't that something? A bonus.
Now we are at T-minus 14 minutes from the launch of the Falcon Heavy, and all systems are go for launch on the half hour.
Fly this thing! Because of you all, so thank you so much. Thank you. Encourage everyone to be in the moment, just experience it. We'll look at the cool pictures later. Except you photographers, you
We don't get to be in the moment.
oh, look at this, that's totally SpaceX party. Look at that.
3 minutes.
So now the pad 39A is lit up, very, very easy for us to see here. And you can feel that little bit of a hush, little bit of a hush. This is, of course, the third Falcon Heavy ever to launch using previously flown cores. And in 2005, you know, the Planetary Society had Cosmos 1 end up in the ocean. If this thing crashed, that would really be disheartening. We'll all do this together, I'm sure. Here we go. 8, 7, 6, 5, 4, 3, 2, 1. Guys, you can see the smoke trails. Even from here, you can see it. Wow! Nicely done, SpaceX. At night, it's just so striking. It's just amazing. It's magical. There they are. Wow, there, two of them. And you can see the clusters of engines. Yes! Woo! There's 2 of them. Yes! Yes! Now, in a few seconds, there'll be the sonic booms going through all this atmosphere to us. Everyone, I want to thank you all for your support. This is yours. Thank you so much. You wow! The sonic boom seconds after landing. It's so amazing. Nicely done. Thanks for making the trip. Nice shirt. Yeah, thank you. Gio, you the man. Bob, nicely done. No, we're not done, but the first hard part's over.
I have him here.
It's so amazing.
I'm still shaking. I know.
Amazing! Oh my God, it was so beautiful.
That was outstanding. Just phenomenal.
I was trembling the entire time, watching our collective sensing element reach further into the cosmos. Like, it's the most spiritual feeling I've ever had in my life.
I'm speechless.
Yeah.
It was no way to describe it. The ground was shaking.
The light of those 27 engines was lighting all of us up, and it's as if it lit up our souls.
Wonderful. It's absolutely wonderful. It was worth the trip from Arizona. I feel like I've been a part of the adventure.
Just the rocket itself, the moon, everything was perfect. The boost is coming back fucking heavy at night
Surrounded by all the members.
Yeah, the Planetary Society here. So it's like it's friends all together.
It's amazing to be surrounded by people that made this thing happen.
It's like a big family, a cozy big family.
Yeah.
Go LightSail! Go LightSail!
Go LightSail!
Here comes fairing separation. We have confirmation of the payload fairing separation. So far, 4 minutes, 17 seconds into flight. Second stage looking good, headed to low Earth orbit, carrying the 24 satellites.
Welcome back to the STP-2 mission as we await the next set of deployments. First up is Prox 1 with the LightSail CubeSat for the Planetary Society.
AOS Hawaii.
Prox 1 deploy confirmed.
It was spectacular. After the launch, you're all caught up, everything shakes, your clothing, your hair, whatever, it's all shaking. Then it's gone. People talking this and that, shaking hands, doing things, all very exciting. But then just as leaving the parking lot, our spacecraft, the Prox 1 spacecraft with LightSail 2 inside, got ejected. And so we watched it on a laptop in the parking lot of the Kennedy Visitor Center. It was really fantastic.
We're getting that other stuff. Oh, listen to that.
That's
Leo.
great.
Totally Leo's
You're in the room across in the operations center.
Cool.
We have
Thank you for doing this.
directly across from us in operations. Everybody is counting down. The go, no go took place about 5 minutes ago, and we are go for deployment.
We're advancing space science exploration thanks to everybody there at Cal Poly, and thanks to our supporters around the world. This is a dream of our founders, Lou Friedman, Bruce Murray, and Carl Sagan. So I am honored to be representing the organization at this historic moment. Our LightSail 2 spacecraft was built by 50,000 people around the world who just think it's a worthy use of their resources, their time and their money, and I really, really appreciate it.
The Cal Poly tracking pass is about 13 minutes long. Then we'll be going over Purdue and Georgia Tech. Simultaneously, we'll switch over transmission from Cal Poly to the Purdue tracking station in terms of commanding at that point.
I've had the experience to run a pass, so I can say I operated LightSail, which is kind of cool. I'm 19. I just finished my first year as mechanical engineering student here. I mean, it's just another day at work, I guess.
I'm Cole, and I've been running some of the operations for LightSail 2. It's the green one
It's just about to go above Madagascar. Every time it goes overhead, we have a window of time to be able to communicate with the spacecraft.
My name is Michael Fernandez. I'm going into my 4th year at Cal Poly studying physics. LightSail is my 5th or 6th spacecraft that I've supported. Out of the projects I've worked on, it's probably the coolest one that I've operated. For me, the past month of preparation with operations has basically just been leading up to this moment of deploying the sail.
Deployment of the solar sail. This is something that the team's been working towards for years. It's been a 10-year program that I've been working with the Planetary Society for LightSail. It's been a great 10 years, and really look forward to this next month where we're really demonstrating the first controlled solar sailing in Earth orbit.
Is the motor count increasing?
It says motor on. Telemetry shows LightSail 2 sail deployment motor is active.
Yep.
Motor active. Motor is active. Motor is active.
The sail's got to deploy. I mean, we're well on our way. Everything's going great so far, but we got to finish it off. We got to get the sails out, and we got to build orbital energy.
135,786. Cell deployment complete.
All right. LightSail 2 sail deployment is complete. All right, thank you guys.
Nicely done, you guys. Congratulations to everyone. That is fantastic. This is just an enormous kilometer marker, AKA milestone in the LightSail program. And so the sails are out, and so expect any moment the photons are pushing the sails higher and higher to a more distant apogee.
This has been a challenge from the beginning to where we are now. We still have challenges ahead as well. But every time we're able to deliver on a milestone, deliver to the expectations of our members and our supporters out there, it feels so good. It's exhilarating.
The spacecraft has been performing just nearly perfectly. We got the radio signal within a couple of seconds of our prediction of when it would become viable to get that signal.
We are sailing right now. Feel the photons. It's a fantastic event for those of us into solar sailing. This is a new type of propulsion using nothing but photons from the sun. It's extraordinary because right now, while we're all sitting here, our LightSail 2 spacecraft is in orbit.
I do two main things with LightSail 2. One, as program manager, I manage the budgets, the team, I approve things that are recommended by the team in terms of implementation. The other thing I do is I'm the imaging lead, the imaging guy. So I figure out when it might not be cloudy and over the equatorial region, which is more challenging than it sounds. I get more excited about a picture than I do a printout of data, although it depends on the data. It can be kind of exciting. LightSail 2 is still doing great, doing controlled solar sailing, and we're actually 2 years into the mission, sailing as well or better than we were early in the mission. We've worked with NASA for a number of years on their upcoming solar sail missions to share what we've learned in our solar sail missions. LightSail actually evolved in part from a NASA mission, NanoSail-D, that did just a deployment of a sail from a CubeSat. We then took it to adding the more complex controlled solar sailing ability and flew it in Earth orbit. And then with NEA Scout, Near Earth Asteroid Scout, they will actually be going the next step of flying out to an asteroid using solar sailing. We're also working with Solar Cruiser, which is a mission farther out that will go even further from Earth and demonstrate a number of things with a much larger sail.
I'm Les Johnson. I work for NASA at the Marshall Space Flight Center, where I serve as the principal investigator for the Solar Cruiser solar sail mission. And I'm also the solar sail principal investigator for the Near Earth Asteroid Scout space mission. The Planetary Society's development of LightSail was in parallel to the development that NASA was doing for the Near Earth Asteroid Scout. We had people observing each other's tests, and anytime you learn from what other people have done is helping you do your job. But even more importantly, there is an intangible benefit that played a big role in the selection of the Solar Cruiser mission for flight, in my opinion. And that is, we were developing a proposal and it was all being reviewed when LightSail 2 successfully flew. And there's nothing like an existence proof that something is possible to convince people to consider something based on that that's very ambitious. The Planetary Society's contribution to the future of solar sail technology has been both technical and motivational. I first heard about solar sails through my first love, which is science fiction. I was probably in high school, and I read a novel by Larry Niven and Jerry Pournelle called The Mote in God's Eye. And it tells the story of an alien invasion fleet coming toward Earth, propelled by laser-driven light sails. When the history of the first mission to Alpha Centauri is written, there will be undoubtedly a section in there on the development, the early flights of solar sails and laser sails that'll mention the work not only of NASA and the European Space Agency and the Japanese Space Agency, but it'll mention the efforts of the Planetary Society as a part of that.
We really made a mark in the history of space exploration, particularly in technology demonstration for a new propulsion technology of solar sailing. And I think that's something for all of us to be very proud of. The whole LightSail program has been developed by small groups of people working in lean shoestring fashions to try to do something that no one's ever done before. And we've succeeded. And right now we operate the spacecraft with a core team of only 5 people. And I think it's a testament to the quality of the team that we've been able to do that. Flying in space.
All right. Oh. Back up. Cool.
I'm sorry.
This idea that you could fly a spacecraft, that you could get propulsion in space from nothing but photons, it's really, it's counterintuitive, so it's surprising. And for me, it's very romantic. I have been charmed or thrilled by this idea ever since I first heard about it over 40 years ago. Everybody, let us gather in the library. There's Dave, there's Bruce. Today we declare mission success. We're going to a higher orbital altitude without rocket fuel, just from the push of sunlight. Hey, second one. we are learning a lot from LightSail 2 right now. In other words, although we've declared mission success and we did this thing that we've been hoping to do for, depending how you reckon, 42 years, LightSail 2 will fly for another almost a year. And we're going to learn a lot about controlling the spacecraft and performance of the sails in the coming months. It's a very exciting time. Go LightSail! Thank you all. To mission success, everyone, to all of you. Go LightSail! Bruce has got a beer sign. All right, I will set aside the first slice. Now let's get people.
Yeah, let's pass these around.
Let's get people, anyone who has a second thumb, really. I think my parents would be very proud of me. My mother was proud. My dad said, Bill, do you have to use the word cool all the time? You're always saying things are cool. Is there some other word you can use? But I think he was ultimately proud, and I think they'd both be very proud now. And I think of them, continually, hundreds of times a day I think about them. My parents were both veterans of World War II. And it was, a stressful time, but people they accomplished mighty things in 5 years. And so let's do something great. Come on, let's do something great. Space exploration brings out the best in us. We solve problems that have never been solved before. And it always leads to extraordinary technologies that we take for granted. People can't tell what side of the street they're standing on without looking at their phone, which relies on global positioning satellites. For me, still, at the heart of the whole thing, are the two deep questions. And the guy that articulated this for me best was Bruce Murray. He said, we all wonder, everyone wonders, where did we come from? Where did we come from? What are we all doing here on Earth? And are we alone? Is there another living thing out there somewhere? There's just got to be something else alive out there someplace.
My name is Sophie Timbers Elizabeth Beard, and this question is for Bill Nye. What is the next step in the Planetary Society?
Well, we're gonna ask you all what you want to do next. People have talked a lot about building another LightSail. We can talk about that, but there's a lot of other fantastic ideas. What would you want to do? What would you want us to do next? What's going to be our next innovation project? And we hope to sponsor a contest among you all to choose the next big thing.
What inspires me about LightSail is that in 1608, Johannes Kepler looked up at a comet and had an idea: solar sailing. This idea seemed quiet for 500 years, but really, it was booming and alive in the minds of generations of scientists. Now, in my lifetime, technology has caught up to the idea. LightSail is over our heads in space right now. Let it inspire you.
Hi everyone, we hope you've enjoyed the premiere of Sailing the Light. Stay with us, we are moments away from a live conversation with Bill Nye, Bruce Betts, and Jennifer Vaughn. I'm Matt Kaplan, and I can't wait to share your questions with these leaders of the Planetary Society. Wow. Thank you, everybody, for joining us for that spectacular premiere. We are so glad to have you on board. I'm Matt Kaplan, the host of Planetary Radio for the Planetary Society, and we know a lot of you out there are members and supporters of the project that you just saw come to fruition in that beautiful, beautiful film. We are going to be taking your questions in just moments, but we also will be telling you a little bit more about the project. We're going to very quickly here get through some introductions, beginning with the LightSail program manager, Dr. Bruce Betts, our chief scientist at the Planetary Society. Then our chief operating officer, Jennifer Vaughn, and another guy, the guy in the bow tie there, who just came off the set of his new television show, and it has not been easy for him to make time for to be able to join us today. Thank you, Bill Nye, the CEO of the Planetary Society. We're so glad that you could be part of this little celebration. Bill, I will never forget that thrilling launch. It was such a wonderful feeling to be standing there with you and so many others on that spectacular day, and to still be celebrating this amazing achievement.
Well, Dr. Betts, thank you, Matt, and thank you all for joining us today. I'm in Montreal, Quebec, in Canada, and we're shooting the show, and it's big fun, but it's very busy. Anyway, hi, everybody. It was a spectacular day. It was a Falcon Heavy. It's a huge rocket. And you just listen to the press, and it's thanks to you guys. Thanks, everybody tuned in. It was, you just listen to the coverage of the launch, and our 5 kilo or 10-pound satellite was like this big news. And I feel really good about that, because it really is a spectacular thing that you all have enabled. We are the first solar sail to orbit Earth. And the controversy when I first started as CEO 11 years ago was that, you couldn't twist, you couldn't maneuver on orbit fast enough to pull this off, and at that time, the Icarus, the Japanese Aerospace Exploration Agency spacecraft, had launched. The solar sail had been deployed, and it turned very slowly. It took a day, 4 hours or so, to turn just a couple degrees, but it worked. But we are able to turn every orbit. And I'm just really, as I like to say, as my mother used to say, I'm proud to know you. So we're advancing space science and exploration thanks to you.
Bruce Betts, my partner for nearly 19 years in the What's Up segment of Planetary Radio. It could be right overhead right now, right? I mean, what's the current status?
Well, it depends on where you live. It only goes to 24 degrees north and south latitude, so not where you are, Matt. It is doing well. We're over 2 years into the mission. We're well into an extended mission, and we continue to solar sail. We continue to communicate daily with the spacecraft. We continue to learn things about solar sailing, about everything from degradation of the sail to how to calibrate gyros to make sailing work better. And we're actually sailing better than we have pretty much the whole mission because of some tweaks and changes we've made. We're always troubleshooting this, that, or the other thing, but overall, it's still going. It's working. We're up there. We're flying.
You've learned to fly.
And still getting amazing images. This was the fourth time I've seen the show. Last night, the third iteration, I was watching it for the first time on a big screen, and that was what that time took my breath away, watching those images. And as we heard from you in the documentary, you're in charge of those.
I am indeed. I'm the official imaging guy. Scheduling them and fitting them in. We have limited data rate coming down, so we take images. We create tiny thumbnails we can downlink easier, and we sort through those to figure out what high-res images to downlink. But yes, I'm constantly trying to figure out interesting places to image that'll give pretty images, but also those images are for engineering purposes. So they're what allowed us to determine some anomalies with the spacecraft and also watch how things change over time.
Anomalies. Is that what y'all call them? Anomalies.
Yes, it sounds better than
problems that you
oops.
can't explain. These are, it's fine. Yeah. No, but you guys are
But,
working on
all things are nominal. All things are nominal now, despite the initial anomalies.
But everybody
okay.
just understand that the Aerospace Corporation worked with us on these cameras, and we were all very pleased about that. And everybody was very interested in the engineering aspects of it, the deployment of the boom, how fast the boom would go out. Would the sails billow like the sails on a sailboat or a tall ship kind of thing? These are all fabulous engineering questions. And I'm an engineer. I love to answer engineering questions. But the images, I don't think anybody anticipated how cool they would be. How just, Matt, you used the word breathtaking. Really, they're just spectacular. And congratulations, Bruce, to you and everybody who's pulling those down. Thank you.
Thank you. I mean, I'm doing
Jennifer
the
Vaughn.
selection and
Sorry.
fiddling, but I wanted to make sure. I mean, this is a whole team effort from Aerospace Corporation, creating them, to the students who worked on this, to now the core operations team, Cal Poly San Luis Obispo and Vestigo Aerospace and Boreal and Purdue. It's a team effort, and it makes it work for all of us.
Okay, now Jennifer, as a member of the team that has made all of this possible, and you go back right to our first attempts to fly a solar sail, Cosmos 1, of course. I'm wondering what stands out for you as you think about this amazing success.
It's a good question. It's been quite a journey, and so many of you have been on that journey with us. It is we've had sad days with Cosmos 1, of course. We lost both the test mission and the full mission of our first attempt to solar sail. That was the Cosmos 1 mission in 2005. Rocket failures for both of those. So when those moments happen, it's humbling, because so much went into getting to that point of being on a launch pad, ready to go. And then never even getting a chance to see whether you would have succeeded or not in space, because you never got the opportunity to actually be in space. So for the organization, that was a huge moment of reckoning to figure out, now what? What do we do? Where do we go? What's our path forward? Do we just walk away from all of this passion and investment and effort and support from our members, or do we move forward? And we were lucky enough to be able to speak to our supporters directly and ask, what do you want us to do? And the answer was, move forward. And by that point, there have been advances, engineering design advances. You learned a little bit about that in the video, that NASA had been working on a drag sail and really looking at sailing in smaller packages. And that gave us an opportunity to not only try again to sail, but really make it a Planetary Society mission, a holistic Planetary Society mission. And we had never done something like that before. With Cosmos 1, we were a key player, but we had partners. This time, we were going to be the ones running the whole show. And so it was this huge step forward, leap forward for the organization to take on that level of responsibility and complexity, that level of funding needs. I mean, this was a whole new level that we had never done before. And it was scary, it was challenging, but it was that kind of good scary, that scary that makes you know that you're on the track of something great, because if it works, this is going to be a whole new model for what we as a Planetary Society really do together. We come together and we could make amazing things happen. And so for me, that was a backstory to answer Matt's question, which is, what's my big takeaway? I think my big takeaway right now is possibility. So at that moment back in 2005, we didn't even know what that possibility was for us yet. And right now I can say we're maybe in a similar state, because we've taken this huge leap forward about what all of us, all of our collective passion can do together. And now we're questioning, okay, well, we made it here. Now what? There's going to be more opportunity to grow and leap and become the next layer of the organization, the next example of the organization ahead of us. So very excited about the possibilities.
So
And
speaking
as a
of,
member
you
of
guys, I just wanted that during my tenure, we came up with the current mission statement to advance space science and exploration. And that is what LightSail 2 is doing. And the future is full of possibilities.
All right, we have lots of questions coming in. As so often happens in these settings, we probably won't get to all of these, but we're ready to take the first of those from those of you who have stuck with us after watching the premiere. And here it is. It's from Jolando171, who wants to know, when the sail is far from the sun, how does it keep going? Well, Bruce, I'm sure this is one for you. Never really gets that much farther from the sun than it is when it's at its closest, right, Bruce?
Well, inertia is a property of matter. Speaking of which, you guys, I got to go. They're hovering. I got to go.
No. Well, I'm glad you could be with us for this long, Bill. Thank you.
And we'll come back to this. Is there a question for me?
We do have. Let's jump down to one for you, and I'll just go ahead and read this. And it's a good one for you, Bill. How do we get people to realize that anything is possible if we work together? And that comes from Jeff.
We join the Planetary Society and support it. Ask anybody on the street in any part of the U.S., any part of Canada, any part of the Earth. How do we get people to work together for a better tomorrow? Through the Planetary Society, of course. I'm not just kidding, everybody. I'm not just being ironic. But the Planetary Society is a member-based organization, and these are people like you who are passionate about space exploration. And people ask, and we've got an article coming up in the downlink about this old idea. Well, why are you spending money in space when we've got all these problems here on Earth? A fine question. But notice how much we all depend on space exploration. We all depend on the weather report. We all depend on mobile phones. We all depend on national defense, no matter what country you're in. We all depend. World peace depends on space exploration, let alone the discoveries we've made about the cosmos and our planet. All of these things, all of our understanding of the stars and our origin as a species on this planet, and the origin of planets writ large, all of that comes from space exploration. So yes, the Planetary Society, with your support, is helping to engage people all over the world in this wonderful enterprise where we go after those two questions. Where did we all come from? And are we alone? And that's what space exploration is all about. They are hovering. They are knocking on the table. You guys, this is a big fancy production with a fancy makeup area, fancy wardrobe person. There's Naomi. And I just got to go. The show is going to be fabulous. It may look like Montreal to people who really know, but right today, it's Houston. All right, you guys.
Thank you, Bill.
Thank you all so much. Let's get out there and change the world. Thank you.
Change the world, and can't
Bill.
wait to see the new show. Okay,
So
we are back.
if I may,
Go ahead, Jen.
sorry, I was going to say, if I may, I would just like tack on, because that was, of course, the right answer, the great answer. But in addition to our passion for space exploration, we're really quite passionate about nonprofits in general. And that is something that Bill touched on right there. So the real value of the nonprofits of this world is to do this thing about bringing people together and working on hard issues over very, very long periods of time. And so for us, that's space exploration, that's advancing space exploration. But really, as a kind of a general answer to that question, nonprofits really they hold that special place of collecting the people who care most about change, and then being able to commit to that change over decades or even centuries in a way that other entities can't, in the way that some for-profits can't, in the way that some government agencies really can't. And so there's really such a value in this kind of structure in the world to really, again, pool our passions and do good in the world.
Thank you, Jennifer. Bruce, let's go back to that question that we got earlier about how LightSail does what it's doing. when it's farther from the sun, which, I think we could take as a more general question of how does it do any of this stuff, including when it's flying toward the sun?
There's a lot. There's a lot here, and you've just added more. Thank you, Matt. The
You're welcome.
light is. Let's review the principles which were talked about in the video and elsewhere. Light is pushing on things. It's pushing on you right now, unless you're sitting in a dark room, and it's just pushing a little tiny bit. So it's irrelevant in normal everyday life. But if you have a shiny sail and a low mass spacecraft, that push is actually is significant. And if you have the sail face on to the sun, then you actually are getting you're maximizing that push. If you're edge onto the sun, just like a sail or a sail, if you turn it edge onto the sun, then you don't get pressure from the sunlight. So what we do is twice in orbit, we rotate. When we're in solar sailing mode, we rotate 90 degrees. And so when we're headed towards the sun, we go edge on. And when we're headed away from the sun, we go face on. And that maximizes the change that we get to our orbit by pushing on one side of the Earth orbit and not on the other. Let me take a little bit broader question, which is what happens when we don't change distance compared to the sun very much in our orbit. But what's the case of solar sails when they're out in interplanetary space and they're headed away from the sun? Well, space, unlike Earth, you essentially don't have friction, you don't have air resistance, you're in the near vacuum of space. And so if you hit a velocity, you will stay at that velocity until you start slowing down due to gravitation and other stuff like that. And so whether it's chemical rockets or solar sails, if you reach a speed then you stop accelerating, you'll keep going. What's neat about solar sails is even though that acceleration, that push is tiny, it's constant. It just keeps pushing and pushing. So you're always accelerating. Now, as you get farther and farther from the sun, that acceleration decreases. So you don't slow down for that reason, but you don't speed up as much once you get far from the sun, which is why the solar sails are most practical in the inner solar system, maybe out to Jupiter and the like, where you're getting a strong push from the sun.
Excellent. All right. Thank you, Bruce. Let's go to another question coming in from those of you who are with us. Joel Martin asks, is there an approximate maximum velocity for the LightSail, and could it be used to explore the outer planets? You've started to touch on that.
Yeah, so I'll take LightSail, our spacecraft, LightSail 2, is at pretty much the same velocity all the time. It's around 30,000 kilometers per hour. Its orbital velocity, it's orbiting the Earth. Is there a maximum velocity for a sail? No, but it theoretically no, other than, speed of light. But you can only accelerate it so much, particularly using the sun. But if you take your spacecraft closer to the sun and then get more push as you go head out, you can maximize your speed. And there's also the concept of laser sails, where you use theoretical future big giant lasers on Earth or in space, and you push hard and build up a very high velocity in that way. So you could do outer planet exploration. You could do even someday theoretically interstellar exploration using these techniques, but it is going to be tricky when you get there, other than to do flybys, because of the lack of an ability to slow yourself down, at least in the case of outer planets. So yeah, it could be used for outer planets, particularly to Jupiter, but it gets tough when you get farther out, although you can theoretically do it.
And our founding executive director of the Planetary Society, who wrote the book on solar sailing that you saw during the documentary, he actually is looking at applications like this, not quite to other stars, but using sails to reach the outer reaches of our solar system and build giant relativistic telescopes. But that's for another day, I suppose. Let's go to a question from Andrew Planet, who happens to be a planetary radio listener I know. Many others as well apparently have asked, how long will LightSail 2 remain in orbit? Isn't it already kind of beyond its warranty?
It's way beyond its warranty, and we don't have a warranty. So things could break at any time, and we can't get the repair people to go out there and fix it. So LightSail will remain in orbit at least for many more months, possibly a few years, and it depends on a lot of variables. We're doing something that, although there have been lots of spacecraft in orbit, there haven't been solar sails with these big areas and small mass at this type of altitude. And so there's just an uncertainty there. There's how well we're sailing. So most of the time and through most of the mission, when we're solar sailing, we are decreasing how fast the spacecraft is coming down to Earth. Because even though we're at 700 kilometers up, you think of it as the vacuum of space, there's still atmosphere. And when you have that big sail pushing into just a little bit of atmosphere, it starts to drop its orbit. And so usually we're just making it drop more slowly. We actually, particularly recently, have actually been seeing some gains in altitude, very small gains. So it depends on how well we sail. It depends on when and if and when something breaks before it burns up. It depends on atmospheric models and what the sun does, oddly enough, because the sun, when there are solar storms and the sun's more active, it inflates the atmosphere and you get more drag. The drag is higher and you come down faster. When it's not active, you don't. So long way of saying it'll be up for a while. We're not sure how long.
Jennifer, we know that some missions end even though their spacecraft are still perfectly healthy. Is the Planetary Society going to continue support for LightSail 2?
Yes, I feel quite confident in saying absolutely. So it took a lot to get here. It took a lot to get here. And although the mission is going a lot longer than we expected, and there are additional operating costs, the difference between what it took to actually get us to space and in orbit and operating, and that incremental ongoing cost is just, you can't even compare. So yes, we are committed absolutely to keeping this mission going for as long as we possibly can. As Bruce mentioned, we never know when something will just break. One day it just stops communicating or something like that. It could happen. It could happen today. But it also could happen 2 or 3 years from now. We just don't know. So we're going to keep going for as long as we can, keep learning about the performance of the sails, keep looking at those images. They're telling us a lot about just changes. Just because we're seeing the changes doesn't mean we fully understand the changes just yet, but we're studying those changes that we're seeing in the sails and the booms and what that might mean. We're sharing all of that with the NASA projects that you learned about on the video as well. So this is really something that we're just so excited to be able to continue to contribute with this aging sail in low Earth orbit. But anyway, so the short answer is yes, 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 yes.
And I will mention just in passing that right now, if you go to planetary.org, I don't want to turn this into a fundraising pitch, but I guess it is. We have an extended mission campaign underway right now where you can help us to make sure that LightSail continues to achieve its full potential. Bruce, there's an auction underway as well, and I note that the 2 items related to us that get people onto WhatsApp, either their poem or limerick or actually get to talk to us, no bids yet. Come on, people. You're going to make us very depressed.
What?
Let's go to another.
This is for Planetary Radio, question. Just to be clear.
That's right. Here is Bill Grew. I think I have that right. How many years away is a solar sail launch to Proxima Centauri? Bruce, I'll throw this to you, but I'll preface it by saying, don't hold your breath.
Yeah, I'm known as the skeptical one, so I'd say it's a very long time. But optimists in the world like Matt, who already told you to hold his breath, will say it's a long time. So it's somewhere between a long time and a very long time. There are a lot of technological A lot of technological improvements, including my speech capability, that need to be improved before we can fly to Proxima Centauri. There's a big difference between flying within our solar system and flying someplace 4 light years away. And the ability to get the speed, communication is just a nightmare problem of communicating that far away with the spacecraft, figuring out what you do on the other end, the instruments involved. And so there are people working on these ideas, and the optimists will say we're within a very few decades. I would say there are just a lot of steps between here and there, and we're taking those first steps. And NASA with things like NeoScout and Solar Cruiser and ACS-3 are taking the next steps. But and I think solar sailing is going to be a really big deal in our solar system in the near future. But Proxima Centauri, I'm skeptical. I think it'll be a while off. Other people are more optimistic. So we'll see who's right.
Yeah, I think a breakthrough starshot, they want to have tiny 1 meter wide sails reach 20% of the speed of light, but even they will tell you we have a long ways to go. Let's get another question in here if we can. And here it is. Ann R. wonders, how does LightSail turn when it's going around the Earth, as you were just showing us, Bruce?
It's my official LightSail 2 model. The very good question. The way we do those major turns or slews, the 90-degree turns, and they take a couple minutes, is using a momentum wheel. So there's a wheel, a little, this big metal wheel that spins up to 6,000 RPM, and we adjust the spin rate on that. And then the momentum being conserved will cause the spacecraft to turn. And then we do the opposite to turn it if we're turning it the opposite direction. We also do minor adjustments using what are called magneto-torquers, which are basically electromagnets, and they push against the magnetic field of the Earth in 3 different axes. So we make small adjustments in all axes to the attitude, the orientation of the spacecraft using the pushing against the Earth's magnetic field. But those big slews are using the momentum wheel, which is one of the more challenging aspects of the mission, is using that momentum wheel, using it right, and figuring out how to do what are called desaturations of the wheel. Eventually, it can spin up to its maximum spin rate, and then you have to find a way to take the momentum out, and that we use magneto-torquers, and we use other modes of the spacecraft. And one of the things we've really been learning over time is how to use the wheel better and how to desaturate and how often we have to, et cetera, et cetera. So that's a long answer to a short question.
And Les Johnson and his folks at Goddard are paying close attention, I am sure. Let's get another question up, and here it comes. Gordon T. Beamer asks, can we use solar sailing spacecraft to clean up space junk? Bruce?
Yes and no. So in terms of using the solar sailing aspect, it's not very efficient. You could use it to propel yourself to space junk and do something with it. But if you change the name and what you're using the sail for and call it a drag sail, then yeah. And in fact, that's being explored, including by people on our team, for future uses where you deploy a sail that may look very much like LightSail. But instead of the goal being to use the push of the sun, the goal is to actually maximize that drag we're talking about. And so now you have more molecules of atmosphere hitting your spacecraft, slowing it down, dragging it towards the Earth, and it's used for deorbit. So a very viable technique that's being used and tested now is to have drag sails built into spacecraft. So at the end of their lifetime, you pop that sail out, which makes it sound much easier than it is, and that slows it down and eventually drags back to Earth much faster than it would have otherwise.
It's the same thing they do on the drag strip, all the time. It works so well for those guys.
It's the same concept with a very different amount of atmosphere.
We are going to stay with you until half past the hour, so we got another little bit less than 10 minutes here, and we'll take as many more of your questions as we can. Here's one from NZ17. What are your favorite LightSail moments from the past year? Jennifer, can you try that one first?
So yeah, no, I know already, and you saw a little bit of that in the video. It was deployment. Deployment was definitely my highlight. Because the launch is super exciting, and it's really great to see this package that you've cared so much about finally go on its way and be where it's supposed to be. But deployment was where I think, and personally, all the nerves were, because that was the moment. If it didn't deploy, we were done. We were done. So being in that room with everyone, with our small but very mighty team, watching the motors and seeing that they were starting to turn as expected, and then getting confirmation that we were fully deployed. And of course, the first images coming down of that deployed sail, and actually the deployment of the sail. So we have images that show it coming out, unfurling little at a time. That was still, I think, the highlight for me. A very exciting moment.
Bruce, what about you over the last year?
Well, over the mission, yeah, everything Jennifer said. Over the last year, a couple things. One is every time an image comes down and gets a part of the Earth in it, especially the part I actually hope to get, and there aren't clouds covering everything, I get very excited. And so there have been multiple moments like that, and then getting the high-res images down and sharing those is one of the personally very exciting things for me. And then seeing our improvements over the last few months with our solar sailing, our attitude, our orientation knowledge, and that translating into more precise solar sailing, and actually seeing some gains in altitude, average altitude, really not for the first time in the mission, but almost so. So just the, wow, hey, we're back and better than ever, sort of.
I just want to tell everybody that a lot of us know people who just can't wait to share the latest image from their vacation or whatever. Multiply that by 5 to 10, and you'll know how Bruce is when he shares one of those with us, his colleagues at the Planetary Society.
Hey,
and do I blame him?
Look at this.
And you're getting really good at recognizing all those different parts of the globe as well. So here's another question from Lashana Lewis. She wonders, are there plans for a LightSail 3? We get this a lot. Jennifer, back to you.
Yeah, I will start this, but I'm going to then pitch it over to Bruce in a minute. So no, there's no plan for a LightSail 3. So for us, we like to think of the Planetary Society's role as kickstarting new technologies. We gather everyone together that cares about that technology. We help find the funding. We help make it happen. And then we hope other people take it on to the next level, which is what we're seeing NASA doing now. So we feel in many ways NASA has taken that next step. That's not to say we'll never do a solar sail project again. The question would be, why us? What's different about it? What's special about it? Why would we be taking it on? So as part of this process of really trying to determine where the society is going to put its focus in science and technology, we have developed a new ongoing call for proposals for great ideas. And so I'm going to pitch it over to Bruce. I used to do the pitch on this one, but now it's a launch program, and it's all Bruce's baby over there. So I'm going to hand it over there.
Sure. So we have our new STEP grants program, Science and Technology Empowered by the Public. And we have did an open call, and we've got proposals, and we're in the midst of, or pre-proposals, we're in the midst of reviewing those. We'll invite a small number of full proposals, and that'll help fill out our science and technology portfolio of projects, because we've always done science and technology projects since the beginning of the organization. LightSail is by far the biggest and most challenging, but we, even during the LightSail period, have had many smaller projects going forward. So we're using STEP now to have a competed international look at what's out there and what can we contribute to that makes a difference, that fills a niche, that does something unique, that kickstarts a technology or raises its profile, which LightSail in the big scheme of things has done. And as Jennifer said, in terms of LightSail 3, I kind of view what NASA is doing with their multiple missions as the LightSail 3, 4, and 5. They're not Planetary Society missions, but we've done what we hope to do, and we're still doing it, which is learn about the technology, but also raise its profile with technology, with the tech community, with the public, and just get the idea out there and prove that in terms of a small spacecraft, you could actually do controlled solar sailing.
Your questions continue to roll in, even though we only have about 3 minutes left in this live Q&A. Understand that we are reading all of them. I'm looking right now at the document where our colleagues are keeping track of them. We appreciate everything that you've had to say and ask us. We'll try and get a few more in here. Here's Jim Barnes. He wonders what happens if the sail gets damaged. A matter of degree, Bruce? I mean, maybe hopefully just a little tiny hole.
Yeah, if you get small holes, and we actually see some damage in this sail, although I'd say only one thing that is pretty sure is a small hole. But other places where the metallized surface is probably delaminating, coming apart, and it decreases your efficiency. And in terms of small holes or micrometeoroids or space debris, if we hit them, there are what are called rip stops, which is a thread pattern shaped kind of like waffle threads that is inside the mylar material. So a rip, even if it starts, will not continue. And so it's really, small holes shouldn't be a problem. Big holes running into a giant spacecraft, that would be a problem, but not a very likely one.
Let's see if we can squeeze a couple more in here before we say goodbye. Mohammed Fayaz asks, can we send a solar sail probe to catch up with Voyager 1 and 2? Bruce, again for you.
Theoretically, yes. Practically, no. And not right now. We don't have the technology to do it right now, but you could, particularly using laser sailing, pushing it with large lasers, or even possibly going in sufficiently towards the sun and then coming back out again. You could catch them. It's going to take you a long time, and we're not there yet. But theoretically, yes. Practically, not yet.
I don't know if anybody can see, whether you will if I move my head, but that's a picture, a painting by Rick Sternbach, the great artist, Star Trek guy, who of dolphins who have flown out to Voyager 1, I suppose, and are kind of looking it over. I don't know if they used a solar sail to get there or not. We'll have to ask.
We're going to need a bigger solar sail.
Let's do one more, and that is from David Lee Summers. Congratulations, David. You get to close us out. Are there any ongoing investigations into whether a multiple turning sail design like Cosmos 1 might be used in a future mission? Bruce, first of all, tell us a little bit about how Cosmos 1 differed from LightSail.
Cosmos 1 was significantly larger. It was more massive. It had a much larger sail area, and it had 8 blades, thin triangular blades, that each rotated separately. And so it had a much more complex system for steering, for turning, for making it all work. It had inflatable booms that open up things. Anyway, it ended up in the ocean, so we didn't find out whether all of that worked. And to my knowledge, no, I don't think there is any active work going on. I could have missed it, but certainly I don't see much. Most people are going for simpler designs, a lot of them the square sail like ours, the square effective sail area, but also a circular or somewhat circular like the JAXA Icaros mission.
I loved what Les Johnson had to say, Jennifer, when he, gives so much credit to the Planetary Society for forging this path, and that profound statement about how he believes that when the history of spaceflight is written, there'll be a spot for the society there.
Yeah, no, it touches me every time I hear that clip, and I think I think it's true. I mean, I do think that this effort, it's going to have lasting power, and has everything to do with the members of the organization and the ongoing support for this project. I should also say it has everything to do with the vision of our co-founder, Louis Friedman. Solar sailing, that was a thing that he knew a lot about, and he saw these opportunities early on, and he took big risks with the organization to get us involved with them. And for a while, it seemed like there was going to be an impossible, as I said, impossible journey to get there, but it wasn't at all impossible. It was very, very possible. We did it. It's making a difference. And I hope everyone who has had a role in this mission feels very, very proud of what you've all done.
Thank you, Lou. Thank you, all of you who have joined us today for this premiere. Of course, Sailing the Light will be available to everybody on YouTube. We hope that you will visit us at planetary.org to stay with us on the LightSail 2 mission and everything else that we are up to, all of our social media channels as well. You'll find us in all the usual places, Facebook, Twitter, and so on. And I selfishly hope that you will also tune in to Planetary Radio every week and then every month for the Space Policy Edition. Bruce Betts, Chief Scientist of the Planetary Society, Jennifer Vaughn, Chief Operating Officer for the Planetary Society. Thank you to you, and to Bill Nye, our CEO, wherever you are, Bill. I think we're done. Again, thanks, and have a terrific weekend.